Good afternoon, everybody. Welcome to the Finger Lakes Boating Museum, our lecture series featuring the formation of the geology of the Finger Lakes, presented by Peter Robbins. Peter is a retired geology teacher, am I correct? And retired superintendent of schools of Haverling in Bath. And the material that he's presenting to you was material that he gleaned when he was writing his master's thesis. So it's wonderfully picturesque and very informative, and we hope you enjoy it. And when you're finished, if you haven't already, if you'd like to wander around the boating museum when you're all done, we welcome you up there as well. If you have any questions, just let me know. Don't ask me questions about his presentation, but any questions about the museum, I'd be happy to answer. Did I tell you my name is Nancy Whiteman? Okay. So, thank you, and thank you for coming. This is delightful to have so many people here. We don't expect to pass the thousands, but we're
Thank you, Nancy. We're in God's country here. The Boating Museum is just a fantastic place. Nancy and her husband Ed and a cadre of volunteers have done a tremendous job in taking these old buildings and putting them back into the shape that they are now, and they're certainly to be applauded for their efforts. And as she says, please walk to the museum because it's really fantastic. It's been going now 15 months, 18 months, something like that. It's
a year here. It'll be a year, June.
Or less than a year, you know. As Nancy said, I taught earth science at Haverling for many years, and then took a couple of other jobs there. But this was my master's thesis. I enjoy doing this talk. I am not a high-tech guy. This is a Kodak carousel projector. The Smithsonian has called, and when I'm done with it, they'd like it back. I told Nancy I would continue to do this until either my bulb goes out or that bulb goes out, and then the show's over. So it's not a high-tech thing, but it's just something I enjoy. I've spent a lot of time doing it, looking at the landform around, and it's an enjoyable thing. And I think what I hope you'll take away from this is that when you're driving around, you will see things and you'll recognize things and put two and two together as to why that is there. We have to start, these old school teachers, you've got to start with a quiz. So that's what we're going to do. This is a Landsat photograph. It's taken from 600 miles up. This is Lake Ontario, and these are just clouds over Ontario. These are the Finger Lakes. This is Rochester. Syracuse is over here. St. Lawrence, up that way. So these are the Finger Lakes. Regardless of how many or what people tell you, there are 11 Finger Lakes, and you all know them in order. The first one on the west side is Canisius. The second one is Hemlock. The third one is Canadice, thank you. The fourth, Nancy's heard this talk before. Honeoye. All right. There are a couple of chairs over here, folks. If you'd like to. Yeah, these are the hard ones. Now the easy ones. Keuka. Oh, yep, I'm sorry. Canandaigua, Keuka, Seneca, Cayuga, Owasco, Skaneateles, Otisco. This is Oneida, not a Finger Lake, and I'll explain later why Finger Lakes are Finger Lakes. Juanita, Lamoka, not Finger Lakes, because they weren't formed the way they're supposed to be formed to be a Finger Lake. Okay? So you did pretty well on the exam.
Test us again.
Yeah. The story started 350 million years ago. This was a shallow ocean 350 million years ago. Shallow ocean. We had a mountain range to the east and a mountain range to the west. And those mountain ranges kept eroding and they kept filling in this shallow ocean. And so it was layer after layer after layer of mud. And as you keep adding these layers of mud, compression takes place and a little cementation takes place. They get cemented together, and these sediments are squeezed together to form shale. It's a very, it's not an exciting type of rock at all. In fact, that's what almost all of this stuff is, a shale. And it's just, and you know, you can drive up along the lake and look into the gullies, and what do you see? Flat-lying layers of rock. If you want to impress people, pick up one of those rocks and say, God, I'll bet that's about 350 million years old. Because that's what it is. It's Devonian, and that's its age. And the higher you go up on the mountain, the younger the rock is, because that was the last layer added. Okay? We don't have mountains around here. You talk about Mount Washington or whatever. They're not mountains. What we had was this shallow sea that got filled up with these layers, and then we had an uplifting. And these layers were lifted up above the water level, and the water flowed out and went different places. The mud was compressed into these rocks, the shale, and so we had flat-lying plateaus. And if you think about it, this is just up on top of Bully Hill. Do you see any mountains sticking up? No. It's as flat as can be. And if you get up into the high areas of Steuben County and look around, you don't see any peak sticking up over there because it was a flat-lying plateau. Then what happened was rivers formed. And the rivers started cutting channels through these layers. So you've got the flat layer, the flat land, rivers flowing on it, and those rivers made gullies. All right? Then we had an ice age. Now, I know, and no disrespect to Al Gore, but we've had global warming before. We've had 4 ice ages previous. And if you have an ice age, you have to have a warming period after that ice age. So we've had global warming for billions of years. He didn't invent it. About 2 million years ago, we had our last ice age. And what happened was ice formed in the Arctic. And the way an ice age forms, I liken it to pancakes. And I like pancakes. I liken it to a pancake. You know how you make pancakes on a griddle? You pour the batter in the center, and the weight of the batter pushing down causes the pancake to spread out the side, the weight of the batter. And that's the same way a glacier forms, the same way an ice age happens. An ice age starts when more snow falls in one year than melts in one year. Okay? So you start the next year with snow on the ground. And then that year, you get more snow. As that snow piles up in the Arctic, it squeezes out the sides. So if you can picture the Earth, that ice is just creeping south all the time. And this is an illustration of what happened. The ice came down, I think, probably as far as Bath, and not much farther than that. But it came all the way down to St. Louis, all the way down into Montana and Idaho. But for our practical purposes, I think it came down just about this far. Now, I said we had 4 ice ages, and I'm only talking about the last one, because every ice age that moves along obliterates the evidence of the previous ice ages. It just wipes that evidence right out, or most of it. So we're just talking about the last ice age. So this is, just picture this as being ice here. This is the Tully Plateau, and you see, they can tell that during the last ice age, that didn't get covered. So any evidence you see there would be from a 3rd ice age or a 2nd ice age, not the 4th one. But I said we had rivers here. When the ice melted, the water went into those rivers, and you can see the shape of the lakes there. The water from this melting ice lobe, a lot of it went this way, and it formed the Mississippi River. Some of it did come down through Seneca and down into the Susquehanna and went that way. Okay? As the ice continued to recede, now ice is always moving forward. I don't want to get too much into glaciation, but the ice is always moving forward because snow is always accumulating at the north. But sometimes, now follow this, sometimes the leading edge melts faster than it advances. Think of being on an escalator or a people mover at the airport. If you're walking slower than the escalator is moving, you're going to go backwards. And that's what happens to the ice. If this is melting faster than it's coming down, the leading edge of the ice is going to recede. All right? So as the ice recedes, all this water finds lower areas to leave, to exit, to get out. So it's a tremendous amount is still going to the Mississippi. This kind of dried up a little bit here, but look where it's going now. Now the Mohawk River formed. Bless you. The Mohawk formed. Okay? As the ice continued to recede farther north, this Mississippi part dried up. That became too high. You still have the lakes, you've got the Mohawk, but what's starting to form here? The St. Lawrence is starting to form. Okay? And finally, you've got pretty much what we have now. The last remaining ice is now coming down through the Hudson. And if you've seen the Hudson, the Palisades of the Hudson, you see how that's just cut those horizontal layers just like a knife. So that's the ice age. So that's what set this whole thing up. Okay? Now, as I said, when a glacier moves along, they call a glacier a river of ice. It's always moving, always advancing, it's always moving south, and it's pushing and gouging everything ahead of it. A glacial valley is always a U-shaped valley. This is up in Cohocton, going towards Canandaigua, and you see the classic U shape of the valley. And the ice moved along and just gouged everything out. You can tell a glacial valley from a river valley. A river valley is always V-shaped, where a glacier is U-shaped. Think about a ride from here to Williamsport on Route 15, now the new Interstate 99. Do you know where Fry's Turkey Farm or Ranch is? Steam Valley Mountain? What are those valleys like? Did a glacier go down through there? I don't think so. Those valleys are too steep going back and forth this way. You'll never find a glacial valley that's twisting and turning like that, because ice can't twist and turn like that. Water can, but ice can't.
Peter, is there anything here about the formation of the terminal moraines? Does that come into play?
Hang on. Hang on. Go ahead. Now, these are the Finger Lakes, and what I've done is I've taken a topographic map and just outlined the lakes. The Finger Lakes are divided into Finger Lakes East and Finger Lakes West. And Finger Lakes East are these lakes, Seneca over. Those lakes were all north-flowing rivers. So, you remember, we had this plateau, we had rivers on these plateaus, and some were flowing north and some were flowing south. Those on the east were all north-flowing rivers to begin with. The Finger Lakes West, from Keuka west, were all south-flowing rivers. And what I've done, you know the shape of Keuka. It's a Y shape. And the reason is because one branch is a tributary and one branch is the main river. Which one's the tributary, east or west side? Which is the deepest one? West. The west side is the deepest one, so that was the main river. It came down through Guyanoga, all the way down like that, and then this was a tributary that came into it. Now you know it was a south-flowing river because a river could never flow along this way and then branch apart like that. And the reason it can't happen like that is because one branch is always going to get more water than the other branch, and the branch that gets more water is going to do more erosion, so the bottom of the river is going to go deeper, and pretty soon that other branch is going to be left hanging up there. So that's how we know that this was a south-flowing river, and the west branch is the main river.
Keuka Lake was formed by a river, not a glacier?
No. Keuka Lake was a river first, then the glacier came along and gouged it out, okay? And then we're going to get to why it's a lake in a minute, okay? But you look at Canandaigua. You've all been over it by Naples, and you know this is Middlesex up in here. This is the bluff. This is just like our bluff on Keuka Lake. Same thing. And this is now a marsh up here. This is a marsh all the way down towards Naples. Look at these. Look at this one. This was Canisius, Hemlock, Canadice. These two, they're a Y-shaped valley, just like Keuka, except they're a little bit higher. Water found an outlet, and it left this part dry. Okay? This is just an old picture of Keuka. You can see the bluff. What else do you notice? You notice how flat it is at the top? That's the plateau. That's the plateau. This is the Appalachian Plateau. And this is, unfortunately, a picture that we've seen too much of the last couple of years. This is the bluff with the East Branch and the West Branch iced up. This one usually freezes first because it is more shallow. How come Seneca doesn't freeze? Or Cayuga doesn't freeze? It has. Yes, it has. 1915 or something like that.
Did it freeze this winter? I think it did.
Oh, Seneca did? I go to Florida in the winter. I'm sorry.
Oh, yeah.
Seneca, folks, is 681 feet deep. 681 feet deep. Do not drop your watch there. You know, the joke they say is if you put water from Seneca Lake in your radiator in your car, because it'll never freeze. Because it's so deep, water reaches its greatest density at 39 degrees, so that cold water, it settles down, and the bottom of the lake is always 39 degrees. Seneca 680 feet deep. Keuka is 480 feet deep. Now the amazing thing about these, water in a stream cannot erode below sea level. That's why the Mississippi or the Nile or any of the big rivers, when they get towards the sea, they don't erode the bottom anymore. They erode this way because they've lost their kinetic energy. Seneca Lake is, 400 feet. The bottom of Seneca Lake is 400 feet below sea level. And that's because of that glacier coming along and just gouging everything out, pushing it forward. Okay? This was what I was talking about with Canandaigua. Doesn't that look like our bluff? You know, you put water in here, you put water in here, and that's, you know, so that's a south flowing river. Naples is to our right on this picture. This is Canandaigua Lake. This is called Bald Hill. And again, you see another bluff, and water used to go up through here.
Where's Canandaigua?
Canandaigua is north.
How far?
This is about halfway up.
Oh,
This is about halfway up the lake. Yep.
so up that valley is Middlesex.
Yes. Middlesex is back, the next valley back,
Okay.
I think. Yes.
Your flow direction on Keuka is strange. Penyan's an outlet, Branchport's an inlet.
And Hammondsport's an inlet. Yep. Keuka Lake is one of the only lakes in the world that has an outlet or an inlet at both both ends. Yep. But there is a current. I mean, there's definitely a current in Keuka Lake coming from Branchport down to the bluff, Hammondsport to the bluff, and then all up to Penyan. Definitely a current.
What's the explanation for that? I know Keuka's higher than Seneca.
Keuka's the highest of all the water, Finger Lakes.
So we're 500 and some feet above sea level?
We're 714. Yep. Yep.
Did that water flow, was that the original water flow, or did it change after the glacier?
Changed after the glacier. Yep. I'll be there. Oh, I'm sorry. Go back. This is, you know where we are? This is part of the quiz here.
Can't read the sign.
This is the Hammondsport School down in here. You're at the hospital. You're at the hospital going south towards Hammondsport.
Whatever it's called, the Fred something.
Going north towards him.
North.
Or going north towards Hammondsport. Yep. This is from Bath. This is between Bath and Hammondsport. All right. This is called moraine. This is called moraine. I call this terminal moraine. Now, you're going to get arguments from geologists about terminal moraine and recessional moraine. And really, the difference is terminal means the end. So when a glacier moves along and it gets to this point and it stops there, it deposits a bunch of material, and that's the terminus. That's terminal moraine. And then as it recedes, remember it's still moving forward, but it's melting faster than it's moving forward. If it sits here for a while and deposits a bunch of material, that's called recessional moraine. Okay? So this is moraine. This is moraine. This is also the hospitals, like right behind me. I'm looking at Keuka Lake. Okay?
So what's the time frame from each one of those?
10,000. Everything I'm talking to you about now, from those first pictures, those first drawings of the ice lobes and everything, from that point to today is 10,000 years. Very, very short in geologic history.
So this is about when you did your math?
That's when I started, yes. Oh, this is a tough crowd, Nancy. Remind me, I'm busy next year. Yeah.
Did you say the ice age started 1 million years ago?
Yes,
So it was like 1 million to 10,000?
right.
Was
Yep.
that the first ice age? or the-
That was the fourth. That's the last ice age. I don't know anything about 1, 2, and 3. I know a little bit. There's parts of Wisconsin that didn't get it for some reason. It just didn't get involved in the ice age and the previous ice ages, and I don't know why. That's another master's degree. So this is moraine, all right? And this is Naples. I'm in Naples, and you remember that one picture I showed you, and I said Middlesex is up here, Canandaigua's here. What's that topography look like? This is what's known as humpy topography. You remember, go back, what were the sediments laid down like? First, 350 million years ago, perfectly flat. Are these perfectly flat? These are all lumpy and bumpy. And the reason is, when the glacier came along, remember there was a river there first, the glacier came along and gouged out that valley, made it wider and deeper and U-shaped, pushed all this material ahead of it. And then when it started melting, it kept dropping the material that it was pushing forward. And this became known as moraine. Moraine is very easy to identify because it's unsorted. It's unconsolidated. You see a great big rock like this, and you see pebbles. You see they have what they call a Wentworth size scale. Boulders, cobbles, pebbles, sand, silt, and clay. And that tells you the different size materials. Like these cobblestone homes in Rochester on Route 104, they're there because the glacier came along, got to that point, Route 104, Ridge Road, and it dropped the material there, and the material were all cobble-sized pieces. Water was flowing. If the water was flowing fast enough, it would take pieces smaller than that away, leaving just the cobble-sized pieces there. But in a moraine, they're all different sizes, like this. And it's just unconsolidated stuff. Okay? This is moraine. All different size stuff.
How far away did that stuff come from?
One of the projects I was going to do for my thesis, instead of what I did do, they do what they call rock trains. And what you do is there's some igneous stuff in here. This boulder here, I think, is igneous. That didn't come from around here at all. That probably came from Canada. And you can actually, if you like rocks, which I don't like rocks, I like landforms, you could take that rock and identify it, examine it, and trace it back to its original place.
Someplace off the Canadian Shield or something?
It's off the Canadian Shield, exactly. Canadian,
Would this have been deposited by?
This was brought here by a glacier. Now,
No, it's igneous, it's not sedimentary.
no, it's igneous. That's how we know it didn't come from here, because everything we have is sedimentary. What else do you notice about that rock? It's round. How come? It's been rolling and pushed, and the ice does tremendous things. This was great, Nancy, to have this room for us. Yeah, that's a rock hammer. Why is that there? Scale. So if I didn't have that there, you wouldn't know, are they pebbles? Now you have an idea of that. All right, now we're going to get into how we know what we know. Actually, the name of my thesis is Recognition of Post-glacial Shorelines of Keuka Lake. Recognition of post-glacial shorelines. All right? And this is the Finger Lakes Boating Museum. I'm not being partial to Keuka Lake, but I just know Keuka Lake a little better than the other lakes, but it's the same story for every lake, the same thing. When a river flows along, it has a certain amount of kinetic energy, and it is able to carry things. The faster it flows, the larger the particles it can carry. And when the river slows down, it can't carry those big things. It's got to start dropping them. And the last thing it can carry is the smallest stuff. Remember boulder, cobble, pebble, sand, silt, and clay? Clay, which makes up this stuff, you know, that's the last thing out there before it's dropped. Well, when a river flows along and it flows into a standing body of water, a river into a lake, the velocity of the water in the stream diminishes, and it has to drop what it's carrying, and it forms what is known as a delta. The reason they call it a delta is because it's shaped like the Greek letter delta. All right? This is a tremendous delta. This is Nick Eunice's Camp Airy on the east side. And up here, there's a big waterfalls known as Eggleston Glen. And if you walk up that, you'll see a beautiful waterfalls. But all this material was brought down and deposited here from up there. Okay? This is, not to be partial to the east side, this is the west side, and this is the 2 Mile Point up from Hammondsport. Lundy, Grove, Glen Grove, you know the sign if you go up 54A, watch for the state policeman. If you go up 54A, it's about 2 miles north.
What restaurant is it? Is it getting?
Snug Harbor. Okay. Snug Harbor's 1 3/4. This is just, yeah.
Now, how old is this photograph?
I took this photograph in the late 60s. Yeah. And I just held the camera real high, and I owe you that one. But you can see this delta, where'd it come from? All this stuff came down from here, okay? But the thing you've got to understand is deltas must form underwater. A delta can't form above water, it's got to form underwater. So what does that tell you about the level of Lake Keuka? Used to be higher, that used to be underwater. Another thing, look at the lines here. This was all vineyards at one time. We don't realize that now when we look at the trees and the growth of those trees. That was around 1900. Everything was vineyards. Okay? Now we're getting there. Here we go. This is Hammondsport, of course. This is the Hammondsport School. This is, what's the name of that road?
Mount Washington?
Nope.
Old
Winding Stairs. You know where I am? Winding Staircase Road.
Yeah.
You know where what's that gas station? Quick Fill. The Quick Fill, that road right alongside of Quick Fill. All right, you know where I am? All right. This, well, go on. All right. I'm going to come back to this. This is Mallory Mill.
Yeah.
This is Hammondsport. This is the Glenbrook, that creek that comes down right alongside of Glenbrook, or right alongside of.
Where's the big concrete sluice?
Yep, that's where the flume. That's where the flume is, right there. You can see it. Yep. This is Reservoir Hill Road. Okay? You know where I am? All right, I'll come back to it.
I'm going forward or back?
Forward, go forward. This is what I want. This is the only good thing about my presentation is these pictures were taken in the 60s and this stuff is all gone. When a river flows along, comes into a standing body of water, it loses its kinetic energy and it drops what it's carrying, and it forms a delta. You remember, a moraine was unconsolidated rock. All different kinds of pieces, just, okay? Look at the layers in here. These layers, like all this material, is exactly the same size. Exactly the same size, all right? Which means this had to be deposited in water. This is the very top of the winding staircase road, which is now gone because they gravelled it. Where was the water?
Well, what, was it because the land?
There's no uplift. No uplift. This is all water. All right, now, Nancy, could you go back 2, please? All right, so what I'm telling you, folks, is that Lake Keuka used to be right there. And all this was underwater, and we know it because of the type of sediment that you're looking at. It's not unconsolidated, it's stratified. It's what's the elevation? The elevation of that is 1,158 feet above sea level. The elevation of the lake now is 714. The difference is 440 feet.
So where's that, all that water?
I'll get you.
Now that, Jack Edwin Evans III, who has been long gone, he told me this 70 years ago, that Bluff Point was an island within, he said, recorded history. I can't quite believe that.
I'll go along with everything until record. Well,
That was the timing was what I
yes.
read. So at one point, that would have put water between Branchport and the East Branch.
Yep. I've got to go back a little bit. You remember the picture of the humpy land at the hospital and at Naples, okay? I said that was terminal moraine. What that means is that material was pushed there and dumped there. And that became a dam. Remember, Keuka was a south-flowing river. And that became a dam, and the water couldn't go any farther because of that material that was deposited there. So the water just backed up, and it backed up to this height. Now,
so this was, you're talking roughly 15,000, 10,000 years ago, the water was at that height?
yes, yes. Now, this, to me, is the neatest thing. That moraine that I'm talking about, where the hospital is, okay? Picture that in your mind. And you know where the Pleasant Valley Inn is. Start there, drive to Bath. What do? You go up the hill. Go all the way up the hill until you get to the hospital. Then you got a little moraine, humpy stuff, and then it goes down the hill to the railroad tracks, okay? All right, so that's moraine. Think of that as a big U-shaped valley, and God dumped a whole bunch of dirt to block that up and make that a moraine, make that a dam, okay? Now listen to this. If it rains in Bath, the water goes into the Bath sewer system, which goes into the Cohocton River, which goes into the joins with the Canasteel River to form the Chemung River, which then flows into the Susquehanna River, which then flows down through Pennsylvania and empties into the Chesapeake Bay, right? If it rains in Hammondsport, the same day, the water goes into Keuka Lake. That water goes into Seneca Lake. That water goes into Cayuga Lake. That water goes into the Erie Canal, or the Mohawk River, which goes to Oswego, which then goes through the Oswego River into Lake Ontario, which then goes into the St. Lawrence River and empties into the Gulf of Nova Scotia. If it rains in Bath, the water ends up at the Chesapeake. If it rains in Hammondsport, the water ends up in Nova Scotia, 1,500 miles away.
Did anybody ever consider making a canal there and connecting these things?
Well,
Like Nicaragua.
yeah. No. But that's called a divide, just like a continental divide, the Rocky Mountains, you know, Atlantic, Pacific. We drive over that divide every day, you know, how many times a week? And we don't realize the significance of the watershed and where that water goes and where this water goes. I think that's pretty cool. But let's go back. So that divide, that moraine, acted as a dam, and the ice was back here. Now I'll go to this wonderful fishing chart that doesn't work because I can't find the fish. But so this was the main river. This was the tributary that came into it. The ice came down, gouged it all out, made it a U-shaped valley, took all that material that it pushed all the way down from Canada, pushed it all down here to where the hospital is, and that acted as a dam. So that was a dam, and as the ice receded, the ice might have gotten back to here. So from here up is all ice. So that's a dam in that direction. So your water was trapped in that valley right there, and it had nothing to do but to go up. And that's why it's right there.
That's a shoreline.
Pardon?
That's a shoreline.
That's the shoreline. It had to be formed underneath water. Remember that. A delta has to form underwater. So if you see, this is the winding staircase road, that's a delta. We know that's a delta because we can see the stratification in the sediment. So it had to be underwater. So the water line was at the top of that level right there.
Pretty cool.
Isn't that cool?
With the bluff under ice?
Is what?
With the bluff under the ice?
Nope, I don't think so. The water level, remember I said that water level to the top of that point right there, or probably a little higher, is 1,158 feet above sea level. And Keuka is 714, so that's 448 feet. The top of the bluff is about 500 feet. So that would make the bluff an island during the last ice age.
An island in the ice.
Well, no, island in the lake.
Oh.
Yeah, island in the lake. And you can see I think I might have that slide for you. You can see the north part of the bluff is very low. You can see that there's probably water in there.
You should have taken a picture of that.
This is a brutal group. I'll tell you. Yeah, there's.
Explain why the hills on the sides of the lake, if you're going north, get lower as you get closer to Branchport, because there was just less water there to build up that.
Well, the reason I think now, we can speculate. And please, if you hear I'm giving this talk again, don't hesitate to come back again, because I make a lot of this stuff up. So each presentation's new. What happens, Matt? And this is getting a little technical, but I said we started with a plateau, flatline plateau. Well, I was kidding a little bit. The land dips to the south 2 degrees, like this. All right, and I'm talking about from Lake Ontario down to Pennsylvania. So we're talking a long way. The land dips about 2 degrees. So picture this. These are the layers of rocks that we've been talking about. All right, if they're tipped 2 degrees to the south, and the glacier comes this way, what's it going to do when it hits that edge? You see what I mean? It's going to, we call it spall. It's going to spall those pieces off, break those pieces off, and if this piece breaks off, this is going to be deeper here than it is here, isn't it? That's
Because it's just gonna go over.
because of the way it's breaking. If it was perfectly flat, the glacier would have gone right straight across it. But because it's dipped a little bit like that, that's why the lakes have varying depth to them, because of that breaking off.
How far north do the shale layers go?
Oh, well, you mentioned the Canada Shield, the Canadian Shield. That rock's 2 billion years old. Now you're talking about real, igneous stuff. The shale, well, I couldn't tell you.
So the Marcellus Shale stops somewhere around the thruway, right at...
Yes, the Marcellus Shale, that's dipping. See, that's dipping and it runs to the surface up towards the thruway because of that 2-degree dip I'm talking about. Now you extend that 2-degree dip down into Pennsylvania and you see why they have more gas there, because it's deeper and there's more pressure on it.
Not to interrupt your talk here, but as you go towards Lake Ontario, does the elevation drop from our area here in the
Yes.
Lakes?
Yes.
So there's that kind of complexity as well. So
Yep.
we imagine that somehow as we move south, elevation drops, but actually elevation drops as you go towards Lake Ontario.
Yes. Lake Ontario is kind of a neat thing. Another thing that you can look at is what they call glacial rebound. Imagine taking 2 miles of ice, which is not how thick the ice was here because we were down towards the terminus. But imagine farther north, 2 miles of ice. That's a lot of weight. Put that on the land, and the land is compressed and goes down. Take that ice off, and you have what is known as glacial rebound. And you can see this, it's so cool. If this is, let's say this is Lake Ontario, and this is Rochester, and this is Toronto, all right? They can actually measure, because this is north and this is south, there's going to be more ice in the north, so there's going to be more weight pushing down. When you take that weight away, there's going to be more rebound, and you can measure shorelines on Lake Ontario that show that land is like this now, because the north shore of Ontario has rebounded more than the south shore. And they can date these by fossils in each one of those places.
What causes the rebound? If the weight has pushed it down, what causes it to come back up?
Just the release of weight. When the glacier melts, that weight is gone. So now the land is able to rebound a little bit. Now we're not talking, we're talking millimeters over centuries, but they can measure that.
In other words, we're not talking about feet, quarters of miles.
No. All right, this going back, this is Winding Staircase Road, and you can see, once you look at these things, you can see that had to form underwater. Okay? This is up in Guyanoga Valley. Had to be underwater. You see these different things. Like this stream that was flowing along that deposited this material had to be going at a certain speed in order to carry that size rock. This stream that was going along here, that had to be going very slow because those particles are very small. Okay? This is taken from Winding Staircase Road. That gravel pit is no longer there. Now, why is there a gravel pit there? Because there's gravel. And why is there gravel? Because it's a delta. But this is Hammondsport High School. This is Hammondsport. This is the Reservoir Hill Road. And that is a delta that's exactly the same height as the top of the Winding Staircase Road. 1,158 feet. So Winding Staircase Road was the delta on the east side. This is called Glenbrook Glenbrook, and this was the top of the delta on the west side. Okay? Now, let's go back. You've got the dam down here, and the moraine that acted as the dam there, and let's say the ice was here, so this was full of water up to the top of the winding staircase road, up to the top of the Reservoir Hill Road. That water had to go someplace, and what it did was it scooted around the side, which is now called the Fish Hatchery Road. So this is the exit of Lake Hammondsport. This is the exit, and the train tracks follow the outlet. So it was still then a south-flowing river. All right. When the water came out the Fish Hatchery Road, it went back. The jail is over here. You can see the topography here that indicates water flowed through there. It went down and it flowed over the village of Bath. It formed Lake Salubria, and we'll talk about Lake Salubria in a minute. That is not a finger lake. I should go back now. Remember, we talked about the moraine at the hospital. A finger lake has to be a moraine dammed lake. That's what a finger lake is. A moraine.
East and west?
Pardon?
East and west?
Yep, yes. Yep, east and west. So that's what a finger lake is. It was a river first. The glacier came along and gouged out the valley. Then it became a big lake, and it was dammed up at the south end by moraine. So it's a moraine dammed lake. Juanita, Lamoka, there's no moraine over there. That's just a wide spot in the river. That's all it is. Okay?
Question.
Yes.
If Keuka was a north-flowing river, why is the north end of the lake so shallow?
Well, can I guess? I'm going to guess because of the flow, and when it was constricted there, what happened to the flow of water? The flow slowed down, so it couldn't carry what it was carrying, so it had to deposit the material there.
The Bridgeport is similarly quite a bit lower, and it's much shallower there.
Yeah.
So it tends to freeze at those
Yes.
ends a lot more quickly.
Yeah.
2 miles below, Bridgeport's one of the deepest points in the lake, up in front of Chateau Hoops.
Yes, it is.
180 feet.
Yep. But some of that stuff, and I'm guessing here, Keuka has many springs. And if you look at a spring at the bottom of a lake, water is coming up and it makes almost like a volcano, a cone-shaped thing. Yeah. And if you have a big spring, I mean tremendous volumes of water coming up, I believe it's going to make cone-shaped things, and that's what makes those holes. There's a hole we found out off waterfront that is 190 some feet deep, and I think that's just a spring there. You know, it's not a big structure. Most of the lake, if you look at the lake, it's just as flat as could be on the bottom, just flat all the way across. This is another example of a good old picture. You don't recognize this at all because this is where the town of Urbana barn now sits. You know where I am? Route 54.
Across from the Curtis Museum?
Across from the Curtis Museum. Okay? You see this little notch right here? That's 970 feet above sea level. And I have found several of those notches at 970 feet above sea level. The reason they're there, in my opinion, you had the dam, moraine dam here, you had the ice dam here. As that ice melted, the farther north it got, it found outlets for that water that were lower than this 1158 level. So as that ice got up into here, that water flowed this way. Instead of going this way, it went this way, and it formed Juanita and Lamoka. And I believe that the water level dropped fairly quickly from 1158 feet to 970 feet. And this was a shoreline. That was where the water was at that point. Okay? I don't know what else much. Oh, what's that? Taganic Falls, folks, is the highest waterfalls east of the Rocky Mountains, 75 feet higher than Niagara Falls. It's 153 feet high. Niagara Falls.
It looked like it was higher.
It was higher,
Right.
but what's happening? The erosion is cutting it right down. Go to Eggleston Glen. You know, same thing. At the end of Taganic Falls, you have a delta, and again, that had to be underwater. Okay.
Is this it?
Yeah, that's the delta at the mouth of Taganic Falls. So that's Keuka Lake. That is the big C, the big red Cornell, and that whole thing is built on a delta. Okay.
Can we see it here?
Pardon?
Is that Cornell?
That's Cornell. Yep.
So that's BB Lake up at the top?
I don't know. This is the big falls.
That's the Ithaca Falls.
Yeah.
Okay.
Yep.
So that's by the high school.
Well,
Yes,
you can
people
see
think
some of the
it's
high
gonna
school
be
there,
nice.
yeah. So the Route 13, the big road wasn't built then?
Oh no, this is a 1960s picture again.
Yeah.
13 was there in the 60s.
All right, now this is we're getting, it's the same idea. This is Kenona. And what do you think used to be in here? A lake, all right? There used to be a lake here, all right? Do you know where John Walsh, his business is on Route 53 going from Kenona up to Prattsburg? You know about where I am? This is Interstate 17 or 86. You know, the big Pilot gas station there now, that's all over in there. Well, that was all a lake at one time. And you can tell that because flat as a pancake. Are you going to find big rocks out in there? No. Not in the middle of a lake, you're not going to find big rocks. Okay? Go ahead. Now, this is just up going towards Prattsburg on that Route 53. You see that hill right there? That's a moraine. Now, what that did, that backed the water up all the way back to Prattsburg, and it formed what is now what we call the muck. That's how the muck formed. The muck was a huge lake up there, and it had two exits depending upon its elevation. One exit you can see here, this is the last one, but the one before that was that flume we were talking about, Mallory Mill. You know that big gully there? That drained the muck. That's why that big gully is there, because all that water that was in the Prattsburg area drained down through by the Boy Scout house there. What shape is that valley? Did it form by a glacier or a river? Had to be a river. No way a glacier could have done that. Okay? So these are the things I'd like you to look at, like you to see in the future. You go to Dansville, you go to Cohocton. What did this have to have been? Had to be a post-glacial lake. Look at that soil. There's not a rock in it. And these, if you know what you're talking about, these are called Kame, K-A-M-E, tame terraces, the water used to be at that level. So that was like there was a delta there, and then the flow of water took the end of the delta away. So it's just a ridge. These are gravel pits. And they're gravel pits because they're old deltas. This is not in focus.
I didn't do it.
No. This is just different. This is a cloud. This is Watkins Glen up here, and you're going down towards Horseheads.
Oh, yeah.
All right. These are what I call chatter marks. See them on there? I think when the glacier came along, remember this was a south-flowing river. When the glacier came along, it couldn't make that sharp turn, and it just chattered around there and chiseled out those marks like that. Okay? All right, this is called a kettle hole. This is the way Lake Salubria formed. If you took a cake pan, a lot of my things relate to food. If you took a cake pan and put a block of ice in it, and then you covered the whole thing with sand, and then you let the ice melt, what would you have where the ice was? You'd have a depression, right? That's how Lake Salubria formed. There was a block of ice, a hunk of ice. It sat there. When that water came out of Lake Hammondsport, went down through Fish Hatchery Road, spilled out over the jail, spilled out over where Lake Salubria is now, it covered all that area with gravel. That hunk of ice melted, and it left a depression. And it filled with water, and now you have Lake Salubria. Is it a finger lake? Nope, because it's not a moraine dammed lake. It was formed by, glacial activity. All right? Now, there's no truth to the rumor that if somebody drowned in Salubria, they would end up in Keuka. Okay? If that happens, that's called murder. Okay? It's impossible. These lakes are probably connected underground with, and I'm not talking about rivers that flow underground, but this rock is all fractured, as you well know, and water goes from one place to another. Remember, though, it's dipping 2 degrees to the south, so if anything, water would flow from Keuka to, towards Salubria. I do know in 1972, during the flood, when the golf course at Bath flooded, and there were a couple of ponds, they could not get the water out of those ponds until they opened a ditch. They dug a ditch from Salubria out to the Cohocton River so that they could then lower the Cohocton River. When they lowered lower Salubria. So when they lowered Salubria, then the ponds on the country club went down. So that's the same water table. Okay? I can't think anything else to say.
North out of Penyan, there's a lot of flat fields. Were they lake?
All lake bottom. Yep. You go up by Dansville. Those beautiful fields when you're up on what's that highway now? 390. When you're up on 390, you look down. I mean, it's just obvious that they were lake bottoms. They're all post-glacial lakes is what they were. Yes, sir.
We had a house in Corning up on a hill south of Corning, and you could go out there in that backyard and pick up fossil rocks that had shells.
Yep.
Real
They were brachiopods. And again, you want to impress people, pick up that and look at that fossil and say, oh, that looks like about Oh, I think that one's about 350 million years old. Yeah, they're brachiopods. We didn't have a lot of stuff, a lot of good, exciting geological stuff going on at that time. So we don't have a lot of good, we have some crinoids, crinoid stems, things like that.
Was that ocean at one time?
Oh yes, absolutely.
So that's the Devonian Sea, and you would also get coral, so you'll find coral pieces as well.
Yep.
So it was salted?
Yes. Yep.
When you said originally the shallow ocean, what, in terms of depth, what do you?
Oh, I'm guessing, but I don't know that there was, I don't think it was probably more than 100 feet. Yeah.
And could you summarize just quickly the timeline? So you had 350 million.
We jumped quickly, didn't we?
Yeah, 350 flat.
Yeah. 350 was flat,
Okay.
and then it was uplifted out of the water.
Yeah.
Now, as I said, there were two mountain ranges. One is completely gone. One's probably the Appalachians, but the one to the east is completely worn away. So it was uplifted. It was 350 underwater. Okay? Fossils can only form underwater. They can't form on top of land, so it's got to be uplifted. And then we had 4 ice ages that, did stuff. And what I'm talking about is just the last one. So this is up. The last, you've got a river, makes probably a V-shaped valley.
And that's at 200 million?
Oh, no, much less. Well, I don't know. I can't tell you. Because each glacier, each ice age obliterated evidence. So I can't tell you that.
But you had mentioned 200 million. What happened at that time?
Well, you've got 3 ice ages that I'm not talking about. So that was all going on during that time. And the last ice age started about 1 million years ago. All right. So I'm talking about from 1 million years ago when the ice gouged out the river valleys, formed the moraines, and now we're back to 10,000 years ago. Okay. So that Lake Hammondsport that I'm referring to is roughly 10,000 years ago, we think.
You had mentioned 200 million years ago. What happened at that point?
So geologic time periods, you're talking about these cooling and warming periods.
Yeah.
I don't know what period that is, but.
No, I don't know the ages of the ice ages. But keep in mind, don't panic about your this global warming. In my humble opinion, it really is not caused by the hairspray that I, have used. As they first thought, that all that hydrocarbon was going up and making a hole in the atmosphere. In the ozone layer. No.
That was a different deal. That was a whole different kind of.
Yeah, but we have these global warmings all the time. Remember, we've only been taking temperatures. We only have recordings of temperatures since Benjamin Franklin. I think it's 125 years, 150 years, which geologically speaking is nothing,
But they're going into ice. They're looking into these ice formations, these kind of glacial formations, and they're going way back into deep time. So all of that's unfolding, and you're looking at CO2 trapped in that ice. So you could say, well, we don't have Benjamin Franklin. Prior to Benjamin Franklin, you could say that you can go into these ice cores.
Yeah, they do ice cores. That's exactly right, and they're measuring. They're measuring carbon dioxide levels and things like that, and that's where they're finding their data.
Yeah.
But I guess my point is, are we enhancing global warming? Yeah, probably, but minuscule compared to what's going on in the world. I mean, it's a world process. It's not something to feel guilty about.
Yeah, the radical shift. So at one time, the Earth didn't have any oxygen on it at all.
Yeah.
In fact, it was.
I mean, you only need a tilt. Our axis is tilted 23.5 degrees. If it was tilted 23 3/4, we'd have a whole different climate. And that could be a meteorite hit us and just knock us off our kilter a little bit, you know.
Peter, next question for you is, where does all of this leave Paul Bunyan?
Yeah, right.
Paul Bunyan? I think he's down at Maloney's.
What's nice about this is that, you know, like we're sitting in this cask room and it's, you know, we're surrounded by deep time.
Yep.
And as the way you're talking about this, and what I really enjoy about it is that when you travel these kind of geographic terrains, we're surrounded by deep time, but we don't think about that.
Well, that what did I say to begin with? I said, what I want you to take out of this is when you drive home or when you drive anywhere, just look at the hills. Night settlement, sand and gravel. I mean, that's a huge gravel pit. Why? Because there was a glacial lake there. You know, any gravel pit that you see, you picture the water had to be above that. You know, I think that's neat. It just makes you look around and appreciate what you have and what a small period of time our life is in this whole thing. You know, it's just, so we better have a glass of wine or something. Thank you very much.
That was great. I
Well,
wish
thank you.
You were my teacher.